Hi, my name is Mary Snow. I'm a software engineer and instructor at Codesmith, which is an immersive residency program to help develop and train software engineers. Recently, we started building an online learning platform that takes people from ground zero of learning how to code and enables them to pair program and do coding challenges together, which is really exciting. This new project, we're working with a lot of React and Redux, and it's being built separate from many of our other applications. So I made it my mission to implement testing across our application, just because we haven't had as much test coverage as I would have liked in the past. But we've encountered similar issues that other people have talked about when it comes to testing. There's not enough time. It's too hard. Where do we even start? Which leads to this question that gets asked, like, why even bother testing when it seems to just slow down the entire development process, right? We could just push this feature out and have it there. Why even bother testing? I know you've heard a lot about this already. But the benefits of testing are maintainability, documentation, and peace of mind. So you have this maintainable code, peace of mind that if I'm working on a feature right now and I have to leave it for whatever reason, another developer comes in, I could have the peace of mind knowing that they're probably not going to break anything. We have tests that are going to cover this code. Testing also serves as great documentation. So if you are a new engineer on a team, or if you are looking at a new piece of the product that you haven't looked at before, it's really nice to be able to go to some of the tests and just look at what is supposed to be happening here, how is this supposed to be functioning. And along with that, peace of mind is great. You don't want to worry that your new change that you've just pushed up, new PR that's been merged, is going to crash anything. That being said, I'm going to talk about testing React applications specifically. And I know we're developers from a lot of different backgrounds, and some of you may not have worked with React. So just to be on the same page, React is the front-end JavaScript library for building user interfaces. It's declarative and component-based code. And when it comes to testing, there are a bunch of different testing tools to look at. You've got assertion libraries, testing frameworks. You can look at different libraries to get mock spies and stubs. And how do you decide what you're going to be using for a team when you haven't really done that much testing before? We focused on just some really good React testing tools. So the first tool is Jest. Jest is built by Facebook, and they say, zero configuration testing platform. Jest is awesome. I love using Jest. It comes with a lot of really nice features out of the box. Built-in code coverage with Istanbul is really nice and really simple to set up. So if you want to have code coverage, Jest makes it really easy. And it also has a watch mode enabled. So that will enable your test to run again when the testing file has been updated. So if you're doing a TDD approach, you write a test, it fails, and then you write a test and it passes, and you save that, you'll see that change right away, which is really nice. And then we also use Enzyme. So Enzyme is a JavaScript testing utility for React that makes it easier to assert, manipulate, and traverse your React components output. So we'll be talking about Enzyme and some of the core Enzyme methods that you can use to test your React applications. So Enzyme uses mock rendering to test if components are being rendered correctly and if components are behaving correctly when acted upon. And these are the things we really care about for the front end. So if we think about the user experience, if a user interacts with our application, we should be able to expect and predict the output of their interaction. So the core Enzyme methods that I'm going to be talking about are shallow, mount, and render. You'll see shallow and mount a lot more than you'll see render, but we're still going to talk about it briefly. So shallow is really good for testing components as a unit. The child components will not be rendered, and it's an excellent place to start for unit testing. So rather than testing out the complete componentry with Enzyme, we can just test the output of the component. So in this example here, I have a component called, very creatively, my component. And there's a counter that's being displayed, and there's a button. And when you click the button, the counter should increment, and that should update our view. So our counter starts at 1, we click it, it should increment to 2. Super basic. So in this test file, I'm importing shallow from Enzyme, I'm importing my components, and I create this wrapper, and I use the shallow method on my component. And then in the describe block, I'm creating 2 different tests. They're both for my component, so they're both in that one describe block. We know that it should start off at 1, so I expect the wrapper text to contain 1. And then for my next test, I expect that when I click, it should increase from 1 to 2. So in this case, I'm taking this shallow wrapper, I'm finding the button, and I'm simulating the click. Now, the simulate method is really interesting because simulate is calling the component's prop based on the event that you give it. So in this case, simulate is actually calling this on-click prop based on the click that I'm giving it. So you can use simulate to call some of your props. And once we do that, just like a user, if they click the button, we would expect that text to now contain 2. So this is just a shallow wrapper. You're not worrying about any of your child components. So if you want to get unit testing, using shallow with Enzyme is a really great way to go about it. There's also something interesting that has to do with props. So inside of this div, I have this included prop that says I'm being included, which I've added. And in this case, I'm also using this shallow as well, but I'm also passing in this excluded prop. So excluded prop is not actually inside of our component. So when I'm running this test and I'm checking to see if this property is included inside of our wrapper, I expect that to match I'm being included. So I expect that this included prop will be there. But if I call wrapper.props.excludedProp, that will show up as undefined. So what's interesting is that if you were to change the way you're calling this, if you call the wrapper instance of props, you're actually returning. So what props does is it returns the value of the property of the root node that the component renders and not the component itself. So if you want to turn props for the entire React component, you would need to use this instance prop. So that's just something that might be a little bit tricky if you're just getting into testing React components, or if you're doing something like this where you're passing in these other properties. Next, we have the mount method. Mount needs access to full component rendering and the lifecycle methods. So React has a whole bunch of lifecycle methods like component did mount, component will mount, and if you want to test these features, you need access to the lifecycle methods, which you can use mount for. So in this case, I have a comments component. I'm using a spy from sign-on, and I'm just checking to see that if the component did mount was called once. If any of you are React developers, you may have encountered some sort of tricky situations where you're expecting your components to mount or not at certain points in time, or just with React lifecycle methods, if things didn't update the way you're expecting them to. We've had a few tricky situations that could have been solved if we just had some tests like this. One thing to keep in mind is that when you're mounting components, they share the same DOM. So if you mount components and update your DOM, then your tests could potentially interfere with each other, so that's something to keep in mind. You can also unmount a component from the DOM as well. And then render. Render is really similar to shallow and mount. It uses Cheerio to parse HTML, and it's really helpful for testing static components. So in this case, if you wanted to test just HTML or JSX and static components, you could use this with the less overhead than mount. But at the same time, you might have some static components that are being consistently changed, right? So maybe instead of having a length of 4, I add some new content, my rows now have a length of 5, and now I have to update this test. That's where snapshots come in. I know someone talked about snapshots a little bit before, especially with Jest. Jest is pretty cool. So when you take a snapshot, it basically just takes just like it sounds, a snapshot, like a picture of what it looks like, and then the next time you make an update, another snapshot is taken, and those two are compared, so you get this nice diff. It's really great for testing UI components that can change in really small ways. So if your copy is changing on your website, if padding is added, if a color is changed, things like this that are going to change but not necessarily impact functionality, you might want to use snapshot testing rather than writing very brittle tests for. So they work really simply with Jest. One potential downside to snapshot testing is that it's not real TDD, because you're instantly taking a snapshot the very first time, so you're not writing your test first. So in this case, if I were to have this component and I create a snapshot here, so I'm importing app, I'm creating a shallow copy, and then I'm expecting my app to match my snapshot. The very first time I do this, a snapshot will be taken and my test will pass. But let's just say I go in and I change this h1 tag to say events, and then this button to say add events. The next time I run my tests, I'm going to get this snapshot failed. So my snapshot failed because something has changed. It's not necessarily a bad thing, it's just a change. So if you can inspect your code and then simply update your snapshot by pressing U. So if I go ahead and inspect my code, you can see here that I've got to do and events. So these are the changes that were made. And what I can do if I want to update them is simply press the U key, and that will update this test. So that makes it really easy to test things that might otherwise be brittle to test. So in summary, I don't think testing has to be painful. I think it's really important part of development lifecycle. Tools like Jest make configuring your tests really simple. And using Enzyme and Jest together for simple React testing can be really helpful. So if you don't know where to start, these are some kind of examples to show you and kind of get you started with that. Thank you.